Magnetism in the hard iron structures of the ship is acquired during shipbuilding, during the building of the vessel in the shipyard. Now, to give you an idea about this, you see in this diagram, this ship is made fast to the berth or at a yard or a dock, and it is situated in this particular orientation. The ship is being built in this particular orientation, and the pink color arrows which you are seeing, they basically represent the magnetic field of the earth. The vessel is in northern hemisphere, that's why you see all these lines are going into the surface of the earth, and the angle at which they are cutting the surface of earth is the dip angle at that particular place. So the ship is exposed to this particular magnetism of the earth's magnetic field. The hull of the ship will lie in this position till the time the construction of the ship is complete. In a yard or in a dock, when you start the shipbuilding, laying down the keel of the ship remains in the same orientation till the time it is ready to be launched for sea trials. So the Earth's magnetic field will keep on affecting the ship in this particular orientation only. So you can see the magnetic field lines are entering from the top deck of the ship and they are leaving out from the keel of the ship. So the hull of the ship lies in one constant direction and is worked upon. When the ship is being constructed, we will be welding the plates, we will be hammering them, bending them, heating them. A high voltage electric current will be passing at the time of welding. So we will be using grinders, cutters, all these instruments on them. So all the ship's plates which are being fitted will be worked upon at the time of shipbuilding. Now, during this entire process, which happens over a long period of time, it may take 1 year or it may take 6 months for the ship to be built. So during this long period, the Earth's magnetic field continuously acts on the hull in the same direction or the same orientation. Now, since we are working upon all these metal plates which are being fitted on the ship, and the Earth's magnetic field is acting on it in the same orientation, it generates permanent magnetism in these hard iron structures. So I told you that hard iron structures are those structures which are extensively worked upon at the time of construction of the ship or shipbuilding. Like, say, for example, a keel plate, a deck plate, a bulkhead. Now, when you are fitting this, let us assume there is a deck plate. You are fitting this deck plate on the deck of the ship during its construction. Now, you will be cutting the plate, making it to size. You will be bending it as required. You will be hammering it. Then you will be welding from the seams. Then you will be welding a stiffener or a longitudinal on it or a transverse beam on it. So all these things, when they are happening and we are working upon this particular deck plate, the Earth's magnetic field is acting on that deck plate in one particular orientation. And this Earth's magnetic field acting on it during all this jobs or work being done generates a permanent magnetism in these structures. Since a lot of working upon is being done, they are hard iron structures, and the Earth's magnetic field generates a permanent magnetism in these hard iron structure. Now, as this is a permanent magnetism, once the material acquires it, it will not then change with time or with the position of the ship. The permanent magnetism, once acquired, remains there in the structure, and it will not change with time or when the ship changes its position. I will further explain this to you using diagrams also, but any doubts coming up to here, beta? Okay, let's try to understand it using more diagrams. Now, since it is permanent magnetism, the poles which are generated, as we have seen, a blue pole is generated where the lines enter the material and a red pole is generated where they leave the material. The poles generated are also permanent. The course or the heading of the ship or the rolling pitching motion of the ship will not have any effect on them. Once these poles are generated, the rolling pitching of the ship, the course of the ship, the heading of the ship, the position of the ship will not have any effect on these poles because these are permanent poles. Now the ship which I showed you in the previous slide, the lines of force were entering on the deck and they were leaving out from the keel. So if there is a bulkhead, let us say you are welding a bulkhead in place, intertank bulkhead, the topmost part of the bulkhead is going to acquire blue polarity and the bottommost part of the bulkhead is going to acquire red polarity, and these poles will remain permanent always, as they are permanent magnetism. The vessel is going to acquire magnetism both in the horizontal and vertical planes. I will explain this to you with the help of diagrams going further. A blue pole is acquired where the lines enter the material, and a red pole is acquired where the lines of force leave the material. Now, as I told you that this permanent magnetism is acquired both in the horizontal direction and the vertical direction. Now, let's try to understand that by making some diagrams. Let us assume that we have a ship being built at a yard which is on the equator. We have a yard somewhere on the equator and the ship is being built. Two ships are being built there. One of the ships is put in the yard heading in the southerly direction. So right now you see where my laser pointer is. This ship is being built in the yard on a southerly heading. This is how the orientation of the yard is. Now, if it is being built on a southerly heading, you see a red color pole here at the bottom or at the south. This is basically the south pole or the south magnetic pole of the Earth. And you see a blue pole at the top or north of the ship. This represents the north magnetic pole of the Earth, which has the blue polarity. And these dotted lines which you see, the dotted lines going from red pole to the blue pole, they represent the magnetic field lines of the Earth. We are aware that magnetic field lines come out of the red pole, which is the south magnetic pole of the Earth. They are all coming out from the red pole. And these lines of force, they re-enter or go into the blue pole or the north magnetic pole of the Earth. So that is why you see the arrows are always from red to blue. Now this magnetic field is affecting the ship which is being built. And all these magnetic field lines, they are entering into the ship structure from the bow side, giving it a blue polarity, and they are leaving out from the ship from the stern side, giving it a red polarity. Why the bow is blue in this case? Because wherever the magnetic field lines enter, that is the blue pole. And why is the stern red in this place? The stern is red because wherever the lines of force come out, that is the red pole of the magnet. So with the lines of force entering into the bow, it gets a blue polarity. And with the lines of force coming out of the stern, it gets a red polarity. Now, let's assume that there is another ship which is being built in the same yard, but in a different dock. and that dock has a northeasterly orientation. So you now concentrate on the ship on the right side. This ship is heading in a northeasterly direction. The south pole of the earth is at the same location. North pole is at the same location. Magnetic lines of force of the earth are moving in the same orientation from south to north. But with the ship heading in the northeasterly direction, now if you look carefully, the magnetic field lines are entering into the ship structure from the starboard quarter side. So you see, starboard quarter is where the lines of force are entering, and that is where a blue pole will be acquired. These lines of force are coming out of the ship structure from the port bow, and that is where a red pole will be acquired. So you compare both these ships now, you see with the change in heading of the ship, the horizontal positioning or location of the poles has also changed. So beta, your doubts up to here?
Yeah, so what will be the dip angle here, sir?
Okay, it will depend upon the latitude of the place, beta. It will depend upon the latitude, but the dip angle is not going to affect the horizontal positioning. It will affect the magnitude, the power.
Okay, because this right now on equator and on pole, it is easy to understand considering it as a two-dimensional thing, because on equator it is entering from side of the ship and moving out from side of the ship.
That's right, exactly. मैं बाद में आपको बेटा इंटरमीडिएट लैटिट्यूड पे भी ले जाऊंगा, डोंट वरी.
वहाँ पे तो सर वो 3-dimensional में सोचना पड़ेगा.
Yes, that's right. That is where we are heading, beta. Great, excellent, Kiran. Okay, अभी 3D पे चलेंगे बेटा. अभी we are in 2D. We will move to 3D. Now let's see the vertical positioning of the poles of the permanent magnetism of the ship. Now for this, let's make another diagram. In this diagram, you can see the earth. And in the earth, we can see the north magnetic pole, which is blue, represented here. And you can see the south magnetic pole, which is red, represented here. And you see the dotted line also representing the magnetic field lines of the earth. You can see from the red pole, the lines are coming out and the lines are re-entering into the earth surface at the blue pole. Now let's assume a ship which is built in the northern hemisphere. You see these two ships on the top. This one is built on the northern hemisphere, at some place on the northern hemisphere. This ship also is built in the northern hemisphere. This ship is being built in the yard, somewhere located in the northerly latitudes. Now you see that when the ship is being built, the magnetic lines of force will be coming into the earth's surface. So they will be entering from the deck of the ship and they will be coming out or leaving out the ship from the keel. So since they are entering into the deck of the ship, it will acquire a blue polarity. And since they are leaving out or coming out from the keel of the ship, it will acquire a red polarity. This is exactly the same situation for which I showed you the diagram in the previous slides also. We saw a ship standing in a yard and the magnetic field lines were going vertically downwards. So they were entering from the deck, giving it a blue polarity, and they are coming out from the keel, giving it a red polarity. So if the ship is built anywhere in the northern hemisphere, it will have a blue polarity deck and a red polarity keel of the ship. Now let's visualize a ship being built somewhere in the southern hemisphere. So this is the ship you see being built in the southern hemisphere. Now in the southern hemisphere, we are aware that the lines of force come out of the Earth's surface. So you see the lines of force coming out of the Earth's surface will enter from the keel of the ship, giving it a blue polarity, and they will come out from the deck of the ship, giving it a red polarity. So any ship which is built in the southern hemisphere will have a blue keel and a red deck. Any ship built in the northern hemisphere will have a red keel and a blue deck. So when you come to know the location where the ship is built and the heading on which the ship is built, you can find out easily what is the vertical and horizontal positioning of the poles. So the same thing is mentioned here. Vertical positioning of the poles depends upon the hemisphere where the vessel is built.
Sir, if the vessel is built on an equator on a heading of 090 or 270, तब तो permanent magnetism 0 ही होएगा उसमें.
That's right, beta. In that case, the vertical pole will not be there at all.
No, it will be only outward ship, sir, right?
That's right. It will only be outward ship, and there will be no vertical poles if it is built at the equator. So बेटा अब आप इसको ध्यान से देखो and जो भी doubts mind में आ रहे हैं please ask me.
सर इक्वेटर में अगर इक्वेटर में भी रहेगा तो भी उसमें मैग्नेटिक फील्ड तो पास होगा ही सर परमानेंट मैग्नेटिक में
Certainly बेटा
में भी तो होगा ही.
बिल्कुल पास होगा बेटा बिल्कुल पास होगा पर इक्वेटर में वर्टिकल कंपोनेंट कोई नहीं है सो वर्टिकल परमानेंट मैग्नेटिज्म नहीं होगा उस शिप में हॉरिजॉन्टल होगा.
सिर्फ हॉरिजॉन्टल होगा.
That's right.
सर इक्वेटर में बिल्ड होगा तो उसमें हेडिंग का कुछ असर होगा क्या?
होगा बेटा
ऑन अ वर्टिकल कंपोनेंट.
यस वर्टिकल कंपोनेंट तो जीरो है बेटा अगर आप इक्वेटर पे शिप बना रहे हो. हॉरिजॉन्टल कंपोनेंट विल बी देयर एंड हेडिंग का इफेक्ट उस पे आएगा बेटा.
ओके सर. सर एक रिक्वेस्ट है अगर आप ये पीपीटी जो आपने जो भी आपका है उसमें आप अगर ग्रुप पे शेयर कर दे तो.
ओके
लाइक क्वाइट शॉर्ट नोट्स हैं इसमें तो थोड़ा रेफरेंस के लिए इजी हो जाएगा. अदरवाइज बुक रेफर करने में थोड़ा टाइम लग जाता है.
ओके 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 ऑल राइट बेटा. मैं वैसे तो जितनी भी चीजें मैं आपको करवा रहा हूँ दे आर देयर इन द बुक ऑल्सो बट आई गॉट योर पॉइंट यू नीड समराइज्ड वर्जन ऑफ दैट. So I'll share it with you. Let me put it in a summary. मैं पूरे notes जो है ना right from beginning to end let me compile it and then I'll share it with you.
Thank you.
Sir,
Thank you, sir.
book कौन सी sir?
बोलो बेटा.
Book which book sir?
बेटा Ships Magnetism ARI publication Ships Magnetism by Captain Joseph and Captain Rewari.
Okay sir.
Ship's magnetic compass, not ship's magnetism, ship's magnetic compass.
Okay.
So चलें बेटा आगे चलें.
सर एग्जाम्स में भी ऐसे ही मतलब यही सारी चीजों के कॉन्सेप्ट के बारे में ही पूछेगा ना सर जो अभी आप पढ़ा रहे हो मतलब ये नॉर्मल जो अभी जैसे वर्टिकल सॉफ्ट आयरन ये सब ही होगा ना.
बेटा आप जो मैं अभी पढ़ा रहा हूँ उसके साथ साथ चलते जाओ. जब ये खत्म होगा तो आप सारे क्वेश्चन आंसर कर पाओगे.
ओके सर.
तो ये जो बुक है शिप्स मैग्नेटिक कंपास इसमें काफी सारे न्यूमेरिकल्स भी दिए हुए हैं.
नॉट इन सिलेबस बेटा उनको काट सकते हो आप. दे आर नॉट इन सिलेबस. जो सिलेबस में है वो मैं आपको कराऊंगा. छोटे छोटे न्यूमेरिकल सिलेबस में वो मैं आपको कराऊंगा. अदर्स यू कैन कट इट आउट. नॉट इन सिलेबस. ओके अगर आप इतना समझ गए हो बेटा तो आपने अगर कभी भी कंपास करेक्शन करवाई हो शिप पे तो कंपास एडजस्टर पहला क्वेश्चन जो आपसे पूछता है वो ये कि विच इज द यार्ड वेयर द शिप इज बिल्ट। दूसरी चीज वो आपसे पूछेगा व्हाट वाज द हेडिंग वेयर द शिप इज बिल्ट। ये दो चीजें अगर कंपास एडजस्टर को पता चल जाएं तो अपने माइंड में ही शिप की कंपास को करेक्ट कर लेता है। सो नाउ यू आर एट ए सिचुएशन वेयर यू कैन विजुअलाइज कि वो ऐसा कैसे करता है। करेक्ट बेटा?
यस सर।
Yes, sir, understood.
वेरी गुड बेटा,
Yes, sir.
कंपास एडजस्टर बन रहे हो तुम लोग अब। सो लेट्स मूव अहेड, लेट्स मूव। Now we have understood that depending on the heading of the ship and the hemisphere in which the ship is built, the positioning of the permanent pole could result in any oblique direction. The permanent magnetism vector could be present in a three-dimensional orientation. You can understand it from this particular diagram. We have this particular ship here, and the permanent magnetism is represented by this oblique slanting vector. This vector represents the permanent magnetism of the ship. One of the poles is on the deck towards the port quarter, and other pole is at the keel towards the starboard bow. So this vector represents the permanent magnetism of the ship. Now to counter this permanent magnetism, to rectify it, to correct it, this permanent magnetism in any oblique direction is split up into three mutually perpendicular directions. We resolve it, or we split this oblique vector in three mutually perpendicular directions. One of the component is split in the fore and aft direction. You can see this is the component direction. This is known as the fore and aft component of the ship's permanent magnetism, and it is represented by alphabet P, Papa. Then you see this second vector, this is the second component. This is the athwartship component of the ship's permanent magnetism, and it is represented by Q, Quebec. And the third component is the vertical component. You can see this particular arrow shows the vertical component of the ship's magnetism. This is known as the vertical component, also called as the heeling component, represented by alphabet R, Romeo. Now, why are we breaking it up into three vectors like these? This is because it is very difficult to counter the permanent magnetism in a oblique direction in any 3D orientation. But when you split it up in three mutually perpendicular directions, that is fore and aft, athwartship, and vertical, it becomes easy for us to counter all these three components one by one. When we do the compass correction, we will see how this fore and aft component is corrected. Then we will see how this athwartship component is corrected, and we will also see how the vertical component is corrected. Doubts up to here, beta?
So it can be corrected only for this permanent magnetism.
Yeah, that's right.
We cannot do anything for this induced because it will change from place to place.
We will do something for induced also, beta. We will put a corrector which changes place to place.
Okay.
Okay.
सर नहीं समझा हूँ सर, ये कंपोनेंट वाला फंडा नहीं समझ में आया, ये मतलब क्या हो रहा है?
ओके, ठीक है बेटा, एक मिनट मैं समझाने की कोशिश करता हूँ. लेट मी सी, हमारी और स्लाइड बाकी है. लेट मी, आई विल एक्सप्लेन इट टू यू. जस्ट होल्ड ऑन फॉर सम टाइम.
सर ये पी कंपोनेंट हमेशा फॉरवर्ड डायरेक्शन में ही डायरेक्ट करेगा क्या, शो करेगा?
नो बेटा, इट कैन बी टुवर्ड्स आफ्ट आल्सो. इट डिपेंड्स अपॉन द हेडिंग ऑफ द शिप.
ओके
ओके, सो let us proceed ahead. बस ये एक दो स्लाइड्स और बाकी हैं बेटा. Let me cover this, then I'll try to explain it in different way also.
Okay sir.
Now coming to the concept of compass work. Correcting a compass is also known as compass work. So what is the concept behind it? permanent magnetism and induced magnetism both cause deviation of the magnetic compass. Now, as I told you, if our magnetic compass is affected solely by the magnetic field of the Earth, it will give us precisely the magnetic directions. Once you have the magnetic directions, you can apply the variation. Variation can be easily picked up from the chart and applied. And once applied, it gives you the true directions. But if you have the magnetism of the ship, permanent or induced, it will disturb our compass, and that disturbance is known as deviation. The permanent magnetism can be easily understood by considering its three components, or by breaking it up into three components. That is the P component, which is in the fore and aft direction, this one. Then the Q component, which is in the outward ship direction, and the R component, which is in the vertical direction. So once you understand these three components of the permanent magnetism, we can cancel it or counteract it one by one. The induced magnetism can also be generated in three different directions. It can be broken up into three different directions. You can have the induced magnetism generated in the fore and aft direction. In fore and aft horizontal soft iron, that could be a fore and aft longitudinal. This is one orientation in which induced magnetism can be generated. Induced magnetism can also be generated in the outward ship direction. In outward ship soft iron, which could be the transverse or the outward ship beams. And it can be generated in the vertical direction, which happens in vertical soft iron. Examples of vertical soft iron are masts, cranes, or funnels, or vertical stiffeners. ओके बेटा, मैं आज के लिए यहाँ पे ही रोक रहा हूँ। हमारी वैसे और 2 स्लाइड्स बाकी थी, बट इफ आई डू दिस तो ये आपके लिए थोड़ा हैवी हो जाएगा. सो लेट मी स्टॉप इट हियर. So are you comfortable up to here, beta?
Sir, comfortable तो नहीं है, but we'll try to manage.
Okay, all right. Okay. अब बेटा, आपने अभी पूछा था मुझसे कि ये जो ओरिएंटेशन है ना, ये आपको समझ में नहीं आई कि ये ऑब्लिक फील्ड कैसे बना, राइट?
सर, मैं जो अभी तक समझा हूँ सर, जो अभी लास्ट आपने शीट जो दिखाया, उससे मैं ये समझ रहा हूँ कि मुझे जो मेरा सॉफ्ट आयरन है, जो हॉरिजॉन्टल इंडक्शन, दोनों को एलिमिनेट करने के लिए ये कंपोनेंट्स को जो है लगाया जा रहा है. दैट्स करेक्ट?
दैट्स करेक्ट बेटा. हमने इन सबको कैंसल आउट करना है. फोर एंड आफ्ट परमानेंट को, आउटवर्ड शिप परमानेंट को, वर्टिकल परमानेंट को कैंसल करेंगे वन बाय वन. फिर HSI को, VSI को कैंसल करेंगे वन बाय वन. इसीलिए हमने इनको ब्रेकअप किया है.
ओके, दैट अब समझ में, आप वो कुछ अब पिक्चर क्लियर हो गया सर, क्योंकि वो मैग्नेटिक कंपास के पास में भी जो 2 बॉल जैसे रहते हैं और वो बनाते हैं जस्ट टू कैंसिल आउट दैट वर्टिकल एंड हॉरिजॉन्टल इंडक्शन ऑफ दिस मैग्नेटिज्म को कैंसिल करने के लिए. ठीक है सर, समझ गया मैं.
नाउ यू थी, अगर आपने इतना समझ लिया है ना, जितना मैंने आज के सेशन में कराया है, थिंग्स विल स्टार्ट मेकिंग सेंस इन योर माइंड. अगर आप बिनेकल को खोल के देखोगे तो आपको मैग्नेट फोर एंड आफ्ट में, आउटवर्ड शिप में और वर्टिकल ओरिएंटेशन में दिखेंगे.
यस सर.
दैट इज व्हाट कैंसल्स आउट दीज कंपोनेंट्स.
यस सर, वो खोला था तो अभी वही दिमाग में आ रहा था कि वो कैंसिल करने के लिए आपने वो PQR का उसका डायरेक्शन आपने दिया है, उसको फॉरवर्ड आफ्ट और आउटवर्ड शिप और वर्टिकल डायरेक्शन. नाउ आई अंडरस्टूड वेरी वेल सर.
एक्सीलेंट बेटा, एक्सीलेंट. ये जो कॉन्सेप्ट है वो
ये होता है उसमें.
या दैट्स राइट, दैट्स राइट. जो ये कॉन्सेप्ट है बेटा, ये समझने में ट्रिकी है थोड़ा सा, एंड अनफॉर्चुनेटली बुक में इसे ना थोड़ा डिफिकल्ट लैंग्वेज में दिया गया है. सो अगर आप ये समझ गए हो देन एक्सीलेंट. द बेस इज मेड. You will be easily able to understand going further. आगे और भी थोड़े बाउंसर्स आएंगे. जैसा आज हैवी था, आगे भी थोड़ा हैवी होगा, बिकॉज ये टॉपिक एज सच, इसमें फंडामेंटल्स बहुत डीप में जाते हैं बेटा. बट आई हैव ट्राइड टू एक्सप्लेन इट इन एज सिंपल वे एज पॉसिबल. सो
सर बहुत सिंपली समझाया है सर आपने इसको। अभी तक का जो भी कॉन्सेप्ट है, जो विजुअलाइज किया है मैंने, मुझे जैसे समझ में आया बहुत इजीली। मतलब अब तो ऐसा लगता है कि अगर कोई मुझसे पूछेगा तो मैं उसको एक्सप्लेन कर सकता हूँ इस तरह से। इस लेवल तक मुझे अभी समझ में आया सर। थैंक यू वेरी मच सर।
ओके बेटा, ग्रेट, एक्सीलेंट। ओके, गुड बेटा, आज आपने काफ़ी इम्पोर्टेंट टॉपिक एक जो है ये समझ लिया है। सो वी हैव completed our target for today. I've already